Okay, so Alex invests $200 each month in a 9% annuity due. The annuity due is the big phrase here that we're going to come back to in just a minute. The first thing whenever we're dealing with an annuity, we must decide, is it accumulation phase or liquidation phase? So for this one, are we in accumulation or liquidation? Accumulation, they are paying in. So it's accumulation. Second thing then we have to decide is, do we know the payment? And we're looking for that lump sum. Since it's accumulation, that lump sum would be a future value. Or do we know the lump sum? So where's the future value? And we're looking for the payment. Well, is the 200, is that the payment amount or is that the lump sum? That's the payment amount. We know the payment. We're looking for the lump sum. So it's accumulation phase. We have the payment, looking for the lump sum. So that's where we're going to start. So that future value is equal to that $200 a month payment times, remember, at 3 open parentheses, 1 plus, what goes next? 0.09 for a 9%. Then what?
Actually, 0.09.
0.09, yes, thank you.
Then we're going to divide by 12.
Divide by 12 because it is monthly. Power of
216.
216. Where's the 216 come from?
18 years times 12 months.
Perfect. 12 months in a year times 18 years is 216. Then what?
Subtract 1.
Minus 1. We'll close the parentheses and then divide by, open the parentheses, divide by 12, and then we close them twice. But now this is where the annuity due comes in. Now that we've done that, we're going to multiply by this initial factor. So 1 plus 0.09 divided by 12. So I'll race you to it.
I'm already there.
Don't spoil the surprise for us.
I know.
Okay. You 106,471.80?
No.
I got 108,074.86.
That's what I got.
Okay, well, let's see what I entered wrong here. My calculator has been, well, it's technically it's my computer screen that's been acting bad all day, so I'm going to assume it's me that's wrong. $108,74.86. Anybody have questions?
I was wondering, in the homework, I couldn't seem to figure out how to do a problem when it was the compound. Let's see it. I wish I would have written down the entire question, but it was like figured daily for 16. It was like 16 or 25 days. I tried it twice, and it seemed like when it was a smaller amount and not in years, I couldn't seem to figure it out.
Was that an annuity or just a compound interest?
I'm thinking it was annuity because I thought all of them this week were about annuities.
If it was in the homework, it would have been about an annuity. If it was in the on the quiz from like last Thursday, it could have been compound interest.
No, so then it was an annuity.
I don't.
Does anybody else remember that there was one about just days? Maybe I'm thinking it was the.
I say I'm thinking you're looking at the quiz from last week, because the annuities, none of them should have been less than a year.
Okay, so then maybe would you go over again? Because I think I got like a couple of them wrong. When it was like short days, I couldn't seem to figure out what percentage of the year, or what portion of the year it was.
Okay. So yeah, before I move on, the big thing here is remembering ordinary annuity. You've got to add that extra little term on here. And that extra term is the same as just that little piece up there. Okay, so compound interest, if you have less than a year, just a certain number of days. So let's see that Pat invests $8,000 at 6% compounded daily for 25 days. So find the future amount and the compound interest. Well, the tricky part with these is figuring out 365 or 360. We've got the 8,000 as your principal, times just one open parentheses for compound interest. 1 plus the 0.06 divided by, this will always be 365 there. So this part's always 365. Then to the power of the 25 days. So I'm getting 8,032.94. Where most people have an issue with these is they want to put 360 in here because they're thinking ordinary interest. But when we're doing compound, ordinary and exact interest only apply for simple interest. When you're doing compound interest, it's going to be the 365 days.
So you're saying if it was ordinary, it would just be the 360?
Yep. But remember, ordinary is only for simple interest. And this isn't simple interest. This is compound interest.
Okay.
So compound interest. Yeah, okay. Yeah, compound interest is always 365. Simple interest you can have ordinary or exact. And ordinary is the 360, exact is 365. But compound is always 365 for a year. Any other questions? Okay, we've got all sorts of fun planned for you guys tonight. So, Stacy is 28 years old. Stacy plans to retire at 65. Stacy hopes to live to, as always, I feel like I'm being morbid when I talk about that, but you got a plan. Let's say family history says 87. If Stacy wants to draw $2,400 per month in retirement at 5% interest. How much should Stacy invest each month at 9% interest? So we're looking at a two-headed problem here. So our timeline, we've got retirement right in the middle here. In this case, Stacy is 87, 65 at retirement. We can go back to where Stacy is now, which is 28. And no polite way to put it. Go up to where Stacy's expected to die at 87. And let's fill in what we know. Each of these has 4 things about them. One is the time. Well, we know the time for both of them. 65 minus 28 is how much? 37 years. 87 minus 65 is 22 years. So we know the time for both of them. The second thing we need to know is the rate. Well, we know the rate for both of them. While paying in, Stacy will earn 9%, and while drawing out, Stacy will earn 5%. Remember, that's typical when you're drawing out. Usually you're converting it over to safer investments, so you're getting a lower rate of return, but you're taking a less risk of loss. Those 2 things you typically know on both sides of retirement. It's these next 2 things that are going to determine what you do. You need to know a payment. Don't know that on either side, do we? Actually, we do. We know the payment on the retirement side, $2,400. The fourth thing is the lump sum, which is a future value on the investment side and a present value on the retirement side. The future value on the investment side is going to equal the present value on the retirement side. The future value is how much they're going to have in there at the end of paying in. The present value is how much they have in there when they begin drawing out. Well, they should be the same, unless they're dropping a large chunk of money right at retirement. We need to know 3 of those 4 to do anything with it. Well, we know time, and we know the rate for both sides. We only know the payment in the retirement side right here. So we know 3 out of the 4 on the retirement side, which means we can find the 4th one. So what we're going to be finding first is the present value here. That present value is that payment of $2,400 times 1, 2, 3, 1 plus 0.05 divided by 12 to the power of 22 years times 12. 264.
Yep.
Minus 1, close parentheses, divided by, tell me what to do next. Open parentheses. 0.05.
Divided by 12,
Careful.
2 close parentheses.
That would be if we were paying in. Remember, this is drawing out. There's that extra term here. Because on this side, remember, this is the liquidation phase over here. So, 2,400 times 1 plus 0.05 divided by 12, power of 264, minus 1, I'm getting 383, 827, 58. Let me know if you get the same. Anybody anything different?
Wow.
Okay, we'll wait for you. They said my screen has been malfunctioning today, so I'm not going to go too far trusting that mine's right.
Yes.
Okay. So now that is the present value on the retirement side. That becomes the future value on the investment side, on the accumulation side. Now we have 3 out of the 4 things on that side. So what we're looking for is the payment, which is convenient because that's what the problem was asking, is how much does Stacy need to invest or pay in each month. So we're going to take that present value to become a future value to get a payment. So 383,827.58 divided by, tell me what to do. Not everybody at once, plenty of time for everyone to participate. Okay, there we go, 3 parentheses. 0.09 now, yep. Divided by 12, because it's monthly. Well, it's not going to be 264 now, it's 37 years. So is that 444? Minus,
444.
okay, perfect. Minus 1, close. 12, yep. No. This is in the accumulation phase, so we're done there. So 383, 827.58. This is going to be divided by 3 parentheses, 1.09, 1 plus 0.09. Do I? Darn it. There we go. Negative number? That's not, well, hey, you can draw money out each month and still retire. I want to go on your retirement plan. I get 108.25.
Yep.
Now you look at that. That is really, to me, that's a big testament for the power of youth. If you're young, I mean, here, starting at 28, which isn't even, like, horribly young to start retiring. I mean, I usually push people to say 23, 24 is when you should really start to invest for retirement. And they lived for 22 years. It's not like they had a short retirement. They were retired for 22 years. And still, they only had to pay in $108 a month, $110 a month in order to draw out $2,400 a month. Yeah, I probably do. I'm sure $110 a month, I know I spend that on food I shouldn't be eating, that's for sure. Okay, let's do another one. Kim is 24 years old and invests, let's see. Let's make this interesting. $750 quarterly at 10.8% in an ordinary annuity. Kim plans to retire at 67 and live to 85. If Kim earns 6.1% in retirement, how much will Kim be able to draw each month? I'm going to give you guys a couple minutes to play with that one. See what you come up with. Let's do a progress check here, see how you're doing. First thing, I like to draw out my little timeline to make sure I know what I have. So we've got now retirement and death, unfortunately. 24 years old now. 67 when retire, 85 at death. We know the time, and we know the interest, the rate for both sides. We know the payment on the accumulation side. So what we're finding here is going to be a future value on the accumulation side, at least in our first step. So the future value is going to be that payment of $750 times 1, 2, 3. What's going to go in here? 1 plus 0.108. Divide by 4 because it is quarterly. 172, good. Minus 1. Divide by 4. Close, close. We're accumulation, so there's no extra term there. So let's see what I come up with. I'm getting $8,062,491.23.
No.
$2 million? Oh, I must have did something wrong.
No, I was thinking it was way off. So don't go by mine. It just seems really ridiculously high.
Let me punch this one again just to make sure. $172 minus 1.
Goldman Sachs, 24.
It is $2 million.
No.
I knew exactly what I did as soon as I started punching in. I had put in divided by 12, and the last one I said divided by 4. So $2,687,497. But you think about it, they started at age 24, paid to age 67, $750 a quarter, that's $3,000 a year. That's a pretty good sum of money going in. That's not a ridiculous amount. That's a very realistic amount if you start at 24 and put in that kind of money. By the way, $750 is only like $125 a month. So now what? That is the future value here. That becomes the present value over here. So we can calculate the amount that can be drawn out. 2,687,497.08 divided by what's going to go in here?
So 0.061.
0.061, okay. Divided by
12.
12, because we're going monthly now. And then?
To 216.
216, good. Minus 1, close. Then what? Divide by, open. 0.061, divide by 12. We're in the liquidation phase, we got the extra term. So times, parentheses, 1 plus 0.061 divided by 12, close parentheses, power of 216, close and close. So that number divided by 1, 2, 3. Well, I did something wrong. Maybe. Try that again.
$527, I think that's right.
$20,000, and yeah, that's what I'm getting. Yeah, no, 05. Be 05, yeah. So they can draw $20,000 a month.
That's ridiculous.
Yeah, that is. Hopefully, a lot of kids leave some money too, huh? Well, yeah. I could probably go through 20 grand a month if I really had to. Bless you. Factors that played into that, by the way. Why is that number so ridiculously high? One is, again, really long accumulation phase, 43 years. 10.8% was a little higher. We've been going like 9% on some of them. Really short retirement, only 18 years. The last one was 22. And we had a high percentage retirement. 6.1 is pretty high, usually around 4 or 5 in retirement. So that's what played into that number being so ridiculously high. But again, it's not impractical. Yeah, go ahead. What was that?
I was just wondering what the answer was again. Okay, I just want to see if I got the right answer. It took me longer.
So, I mean, even if you lower that interest rate from 6.1 down to like a 5 flat, you're still drawing $16,000, $17,000 a month. Well, you can actually figure inflation goes on the average of about between 1% and 2% a year right now. What? Somebody just tell me how much do you think it takes you to live for a year right now? 25, 30,000? Yeah, what?
You were like barely making it, or just eating, or like all the frugality?
Well, living comfortably but not luxuriously.
About 26,000.
26,000? Okay. $26,000 a year right now. So now this person is going to retire in 43 years. So how much would you need in 43 years? Let's go high end, so 2% a year. We're going to compound it once a year, so I'm going to divide by 1 for once a year. To the power of 43, because that's once a year for 43 years. That's just compound interest now. So that 26,000 a year now in 43 years would be about 61,000. 60,922. Now 2% inflation is quite high. There have been times, I shouldn't say it's quite high, because in the late 70s inflation was pushing 10 or 11% per year. That wasn't good. Right now inflation is running about 0.7 or 0.8% a year. So if that were only 1%, how would that change it? I'm taking some shortcuts on my formula here. It would be 39,883. So that $26,000 a year lifestyle now is going to require somewhere between 40 and 60,000 in 43 years, depending on how inflation goes. Now, I know that's quite a large range, but it's hard to say. In another 20 years, we could hit hyperinflation like we did in the late 70s and have 8-9% annual inflation. I'm hoping not. Okay. Let's do one more like that. Let's say Charlie is 18. Charlie's really got his stuff together. And plans to retire at 68 and live to 91. Charlie hopes to draw $4,000 a month at 5.7% during retirement. How much should Charlie invest each month at 11.2%? So we're looking at our timeline. We know all the ages, so let's fill them in. 18, 68, 91. Let's fill out the times. 18 to 68 is how many years? Careful. 50, right? 68 to 91? 23. Do we know the rates during the accumulation phase? That's the 11.2%. That's monthly. During the liquidation phase? 5.7%. And also was looking at drawing monthly. The 4,000 goes on which side? Liquidation side. 4,000 per month. So it's the liquidation side that we know the third piece of information. So we're going to be able to find the present value on the liquidation side. How do we find that?
4,000. And 2 brackets.
Okay.
1 plus 0, 5, 7, divided by 12.
Okay.
I gotta get my calculator.
I believe it's 276.
Yep, you're right.
So minus 1, close parentheses, then what?
Then we're dividing
Yep.
by 0.057, 0.057, divided by 12,
Yep.
and then we're multiplying, and then we're doing another set of parentheses. 1 plus 0.057 divided by 12, parentheses, 276, and then 2 parentheses.
Cool. This is the the liquidation we're drawing out, so we have that extra term in there. 4,000 times 1, 2, 3. Okay, I'm getting 614,409.85.
Not there yet.
So in order to draw that 4,000 a month for 23 years, 5.7% interest, Charlie only needs about $615,000. So now we need to figure out what Charlie has to put away each month while he's saving. So we're making the payment, monthly payment. So it'll be the 614,409.85. Then what? Divided by, I'll give you the three parentheses.
1 plus
0.112, yep.
divided by 12,
By 12.
parentheses 276.
Careful. 50 years now. 600 months?
Yep.
Minus 1 in close, and then what? Divided by open parentheses. 0.112. Divided by 12, and then we close them up. When we're paying in, we don't have the extra term. So we've got that divided by 1, 2, 3. 1 plus 0.112 divided by 12. Close power 600. Now I'm just going to warn you, this is going to be very shocking just because of the 600 payments. Let me know what you get as they come out. $20.85. Yeah. If you start at 18, yeah, at 18. If you start saving at 18 and put it in good investments, $25 a month starting at 18 will give you a very nice retirement. So I mean, something to preach to your kids and grandkids and their kids and everybody else. It's too late for me, but it's not too late for some of you and for all our kids. Any questions? Now, I'm going to pose a question here. We're not going to answer it till we come back from break, but I'm going to put it out there just, well, give you something to stress about while we're on break. Tim is 26 and plans on retiring at 66 and living to 86, all very convenient ages. Tim wants to draw $4,500 a month at 4.2% in retirement. At 40, Tim wants to use $140,000 to buy a house out of this fund. How much should Tim put away each month at, let's go, 9.8% to make this dream all come true? It's about 2 minutes early for our break, or well, a minute early for our break, but let's go ahead and start it. Give you something to think about for the next 10 or 11 minutes.